Hello, good morning. This is from B.Vijayakumar, Assistant Professor, Department of Physics, SNS College of Engineering. Today we discuss the case study on smart materials. The smart material we have used in lot of places in our day-to-day life in a different applications. So that material we discussed in our today topic, and what are the characteristics and what are the properties must be changed from the material of smart way that we discussed in today. So the first we discuss the introduction of the smart materials. The material changing sufficiently to the form of one or more the property such as color, shape, size in response to externally applied stimuli such as stress, light, temperature, moisture or pH and electric or magnetic field. So in external force is applied, the material to change in shape, color or size is called as a smart material. It's a form of sometimes physical property and in sometimes it's a form of chemical properties. So the smart material, it's a classified in a different way of changes in a material properties that we classified in. One is a piezoelectric material, magnetostatic material. This two is a production of ultrasonic, and third one is a thermoelectric material. And shape memory alloy is an advanced material. Then radiological fluids, then others. So this all is a important material we have applied in the many research and application oriented in our industry sites. So first one we discuss in piezoelectric material. This material under the working of piezoelectric effect. So it consists of sensor, micro or heterophones and power generators. So the mechanical energy is converted to the form of electrical energy. So this is the energy conservation to the form of one to another. So the actual mechanical, that means a pressure or force to change of charge or voltage to the converter of electric energy. So the vibration we call this a strain, then it's converted of electric field of voltage. So it will be used in the SAW filters, then imaging or sonar, then transducer, then transformers. So this is the most application oriented materials. The second one is a magnetostatic materials. So the force is applied, is a displacement is formed to the form of structural mode. The second one is magnetic model, is a current is applied, the voltage is given. Then material mode, it's a form of the both to the form. So the material magnetostriction Fe is a Curie to the form of 14 ppm and temperature is 633 Kelvin. And also to the form in other material in this table we have checked to the form of classification of magnetostriction materials. The third category is a thermoelectric materials. So the thermoelectric materials is used in p-type and n-type element to the form of heat zinc. So this is become used in this diagram is a form of thermoelectric materials. So the electric will be given, the thermo, that means the temperature will be produced from that. For an example of thermocouples. So the fourth category is a SMA that we call this a shape memory alloy. So the shape memory alloy we used in many places. This metal is remembers that the most of in dental architecture wire, aircraft and then the coffee makers. So the heat, not only for heat and load is also to be applied to change of this structure and return is back in the same of the structure. So that we call this a shape memory alloy. Then fourth one is in a rheological fluids. This fluids, it's in a irregular motion. To the field is applied, it's act a regular motion. So this is a form of new types of material to get in a new types of structure to apply the field. Then the future, that means the future of the smart material, it's a form of 4D material. We know that the 2D and 3D materials is based on the dimension, but the future of the smart material is in a case study of conclusion we discussed the 4D materials. Structure that can modify its shape, memories the shape and return to its after deformation. So this material are created through 3D printing. Its market that is just starting in 2019 and it's expected to the reach of 537.8 million dollar by 2025. So the ionic polymer metal composite IPMC we used in this form of 4D materials. So this all is a 4D material toys. Look at that. The dimension changes and color and properties and minimizations and the quality. So this is all to be exposed in good to compare in 3D. So we form in the 4D toys. So this is all the reference I am prepared from this PPT. Thank you very much. We discussed in another one case study in another one topic. Thank you.